Hi everyone, this is number 4 from the 2.4 day 2 worksheet. I know we've had a lot of questions about it and I thought it would be good to have a video for it so you can go back and listen again and again as we are learning about these types of problems. Okay, so the question said find the equations of the two lines tangent to the graph of f of x when f of x is 4x minus x squared, and it passed through the point 2, 5. So first of all, I want to draw in there what that kind of means. So there's the point 2, 5, and there's the graph of that curve. So we're talking about two lines, one going off to the right and one going off to the left approximately. That would be tangent, okay? So my graph isn't perfect, but you get the idea, right? So we are looking at trying to find these 2 points here and here so that we can write the equation of the lines. So basically what we're looking for are two slopes. The big piece of the puzzle here is that the two slopes, so the slope of the right line and the slope of the left line, are also slopes of lines tangent to this graph, okay? So multiple steps we're going to take to figure this out. If you have questions after you watch the video, please go ahead and add them to the question document. Okay, so first of all, what you want to do is you want to find the expression for the slope of any tangent line. Okay, so basically that means you're going to need to do a limit. Okay, so we just want to find the expression that would stand for either one of these slopes. So we're going to use the limit as h approaches 0 method. And remember that formula looks like this: f of x plus h minus f of x over h as h goes to 0. So we're going to fill our formula in and complete this limit. So the limit as h goes to 0, and then we're substituting x plus h in for x. So x plus h minus x plus h squared. And then we're going to subtract the original function here, 4x minus x squared. And this is all over h. Let me remind you that AP takes writing things down correctly very seriously. So leaving off that limit out front could definitely be detrimental to you on the AP exam. So just keep that in mind as we're going through this. I'm going to skip some algebra steps here, but know that you do not have to. And also know that one of the biggest mistakes that students make in calculus is incorrect algebra. So if you struggle with algebra, maybe skipping steps wouldn't be a good idea. So I distributed the 4, squared the x plus h, and distributed the negative in here as well. And when you are solving these problems with the limit as h goes to 0, all of your terms that do not have h's in them should go away, meaning I should only be left in my numerator after I distribute things that have h's. So you can see here everything that's left over has an h in it. That is because I need the h in the denominator to go away. And if I have terms that don't have h's in them, then they won't cancel. Okay, so here we are. Can cancel out these h's. I'm left with 4 minus 2x minus h in the numerator. As h goes to 0, I am left with 4 minus 2x. And this is the slope of any tangent line, so my expression. Okay, I'm going to need that expression in just a second. Okay, so now I'm going to go back up and look at that graph. Okay, so I found an expression that represents the slope of each of these lines, but I also want to write the slope of a line in good old-fashioned Algebra 1 format. So I'm just going to call this point right here, any point on the graph, I'm just going to call it xy. Okay, so I can find the slope between 2, 5 and xy just by, again, using good old-fashioned Algebra 1 slope. So I'm going to go back down, And I'm going to write the slope, a little more space here, from the point x comma y to the point 2 comma 5. Okay, so I'm just going to do y minus 5 over x minus 2. So that's the slope between those 2 points. But we also know that the slope between those 2 points, since that's a tangent line, is 4 minus 2x. That's what we just found from up here. Okay, so they're equal to each other. So now I have an algebra equation that I can start working with. So I'm going to go ahead and I'm going to multiply x minus 2 to the other side. And I'm going to go ahead and distribute that. I'm going to distribute and combine like terms all in one step, just because I think it'll be faster, right? So I'm going to get negative 2x squared. Then it's going to be plus 8x minus 8 on the right-hand side and y minus 5 on the left. Okay, well, I'm going to add 5 so that I have all the x's and constants on the right, and I have y on the left. Now, if you're watching this for the first time or you haven't attempted this problem yet, you're probably going, what in the world do I do now? Because I have this y and I have x's, and how do I solve for x if I've got a y in the problem? Well, here's where a big jump has to happen. An extra understanding of what's going on in the problem has to occur. And sometimes it's hard when I'm on the screen and you can't see everything at once. So I'm going to go back up to the top. And I'm going to remind you in 2 different ways what y actually stands for. So if I look at this graph, this point right here is x comma y. And that point, x comma y, is on this curve. And that curve is actually defined as x comma, here's the actual y, right? So we know that f of x is actually the same as y. So that y that we're talking about here is actually 4 minus x squared. 4x minus x squared. So I'm going to take that, the function itself, and plug it in for y in my algebra problem. So all the way down here at the bottom, I'm going to put 4x minus x squared in for y. Okay, so now I only have x's. So now I can solve for x by moving everything to the other side. For the sake of my sanity, I am going to rewrite this without a negative leading coefficient. Of course, you guys should be capable of doing that with the negative there, but that's okay. So here we are. We end up with x equals 1 and x equals 3. Well, what are these? What do these x equal 1 and x equal 3 stand for? Well, remember what we were doing from the very beginning. We started by finding an expression for the slope of the tangent line. We wrote out the slope of the line using regular slope formula, and we solved for x. So all this is basically telling you the x values where those tangent lines are occurring on the graph. Okay, so these, get a different color here. So these 2 values right here, well, that didn't work, are the x, I don't know what's going on, the x values where the tangent line touches the function. Okay, so there's 2 of them, which we saw when we graphed that there was 2 of them. So 2 locations. We have it when x equals 1 and x equals 3. And we are asked to find the equations of the lines. We're not actually asked to find the points. We're asked to find the equations of the lines. So to find the equation of a line, you need slope and you need a point. Well, you were given the point at the very beginning of the problem. It said find the equations of the tangent lines that pass through the point 2, 5. So we already have 2, 5, so we don't even have to find another point. We could if we wanted to. I'm not going to. We have the 2, 5. And we already know how to find the slope. We just have to use it, find it. So we know we did this in the first part of the problem. The expression for the slope of the tangent line we found to be 4 minus 2x. We could also find the y value of this point and find slope between the point 1 whatever and 2, 5. You could do it that way as well. But we're going to use this expression because that's the powerful piece of the tangent expression here, is that you can actually use it for any value. All right, so when I put 1 in for x, I get the slope as 2. And when I put 3 in for x, I get the slope as negative 2. So now I'm just going to write two equations. So y minus 5 equals 2 times x minus 2. So that's the first one. And the second one is y minus 5 equals negative 2 times x minus 2. I'm going to go ahead and use decimals and graph these two lines so that you can see exactly what's going on. So when you graph both of them, they go through the point 2, 5. And if I were to graph the points that they touch at, one of them is at 1, 3. And the other one is at 3, 3. So here's the tangent line. Here's the other tangent line. Here's the tangent point right at 1, 3 and 3, 3. And you can see the lines as they have been graphed. I hope that helps it make more sense. Please make sure that if you don't understand, you send us a message.